The Kikai caldera is being recharged, and that might trigger one of the most destructive eruptions we've ever seen. It would not only destroy parts of Japan, but also affect the lives of millions of people around the world. And if this new study is right, Kikai might not be the only threat. Other massive calderas like Toba and Yellowstone could be on the same path. The Kikai caldera is an active volcano system near Kyushu Island. Unlike traditional volcanoes with a visible peak, a caldera is a giant crater left behind by past eruptions. In Kikai's case, much of it is hidden beneath the ocean, so it's hard to know exactly when it might erupt. But scientists just found a large magma chamber beneath it, and it is slowly filling up. That's super concerning because we're talking about one of the most dangerous volcanic systems on Earth. Around 7,300 years ago, it triggered the largest eruption in our current geological era. It spread ash and rock across 1,700 square miles. That's like 3 times the size of Los Angeles. This event is known as the Akahoya eruption, and it was probably what wiped out a prehistoric community living there at the time, known as the Jomon people. Kikai has not done anything nearly that dramatic since, but the next major event may be closer than we think, because that huge magma reservoir scientists have just found is probably the same one that fed the Akahoya eruption. The problem is that the magma inside does not appear to be leftover material from that ancient blast. It looks new. That changes the story completely. This is not old heat slowly fading away. It's a big volcano being recharged, and that raises new concerns about its potential to erupt again. The stakes are now much higher than they were 7,000 years ago. Back then, the region was home to scattered communities. Today, an eruption like this could affect the lives of 120 million people. Volcanic ash could cover a huge area, destroying homes and shutting down electricity, gas, and water services. It could also block roads and highways, paralyzing transport and cutting off food supplies. The destruction would not stop in Japan. It could also trigger tsunamis and earthquakes later on. At the same time, volcanic ash could block sunlight and lower global temperatures. That damages crops, leading to food shortages around the world and major economic losses. Even if nothing like this happens, this discovery still matters. It puts us one step closer to understanding when the next big eruption might happen. Researchers now want to refine the methods that worked so well in this study, so they can better understand how volcanic systems are refilled. If they succeed, we may find that other giant calderas like Yellowstone and Toba are on the same path. And by spotting the warning signs of a giant eruption earlier, we could have a better chance of protecting ourselves. Not an earthquake, but a mega earthquake could happen in Japan. It's scarier, bigger, and more destructive than ordinary tremors. However, the problem is that it will occur underwater, which means it will trigger a giant tsunami 100 feet high. A column of water nearly as high as a 10-story building will collapse on coastal cities, wiping out hundreds of houses. The water flow can destroy everything in its path like a bowling ball that knocks down pins. And then another wave may come, and another one. Anyone who is at risk should be on their guard. How to survive? You'll find out later in this video. But first, let's find out what a mega earthquake is. This is an earthquake with a magnitude 9 or more. This is a very rare phenomenon, and it depends not on the power of the shock, but on the length of the fault where it occurs. The longer the fault, the stronger the earthquake. But what are these faults? These are cracks in the rocks of the Earth's crust that move relative to each other. Imagine a large puzzle where every detail is a giant tectonic plate. When one part of the puzzle moves away from another or when they collide, that's when earthquakes begin. If the fault between the parts is long, then the magnitude of the earthquake is great. The largest mega-earthquake ever recorded occurred on May 22, 1960, in Chile. The fault was almost 1,000 miles long. It's almost half the way between Chicago and Los Angeles. And now, a similar mega-earthquake can happen, underwater. That's how it all started. Last year, on August 8th, at 4:42 p.m., an earthquake with a magnitude of 7.1 occurred in southern Japan. The tremors appeared off the coast of the mainland island of Kyushu. Everyone was terrified as they expected a large tsunami to appear. But fortunately, they faced only a small wave. It collapsed on the shore, but didn't destroy buildings. About 15 people got hurt, which is sad, of course. But it could have been worse. It seemed that the disaster had passed. The residents breathed a sigh of relief. However, after that, the Japan Meteorological Agency sent a warning about a possible mega-earthquake that could be incredibly devastating. A previous earthquake of 7.1 magnitude could be a harbinger of an impending catastrophe, a disaster that could affect 250,000 people. As soon as people heard this, they ran to buy groceries. Increased demand and a slight panic led to shortages of rice and several other basic products. People were stocking up on food and preparing for the worst. But a week later, the Japan Meteorological Agency canceled the warning. It turned out that the small tsunami on Kyushu Island was not a harbinger. No one knows whether a mega-earthquake and tsunami will happen in this region, but the chances are very high. To understand the nature of this danger, we need to dive underwater in a place called the Nankai Trough. It is a 500-mile-long underwater fault that runs almost parallel to the Pacific coast of Japan. This is where the two giant sections of the Earth's crust meet, the Philippine Sea Plate and the Eurasian Plate. And the Philippine Plate is subducting and slowly slipping under the Eurasian Plate, on which Japan is partly located. During this movement, the plates get stuck, accumulating energy. Afterward, when they move and align again, they release a powerful burst of energy. And this energy is capable of causing one of the most powerful earthquakes in the world. Experts report that the probability of a mega-earthquake and a tsunami is about 80%. Over the past 1,400 years, mega-earthquakes have occurred every 100 to 200 years in this region. The last time this happened in Japan was in 1946. The entire country felt a powerful tremor that destroyed 36,000 houses in the southern part of Honshu Island. Every year, the probability of a repeat of this disaster increases by 1%. And do you know how many years have passed? 79. According to experts, a mega-earthquake with a magnitude of 8 to 9 can trigger a tsunami that will flood small islands off the coast of Japan. And areas with large populations on the islands of Honshu and Shikoku can be flooded in minutes. Hundreds of thousands of people are at risk. It can be billions and even trillions of dollars worth of damage. According to some reports, about 530,000 people may lose their homes. To save lives, the country needs to carry out a large-scale evacuation. But the problem is that no one knows the exact date. In general, no one in the world can predict in advance when the next big earthquake will occur. In the case of the Nankai Trough, it can happen in a few days, or a few years, or even centuries. So, what should people do? Prepare. Japan has been experiencing earthquakes for a long time, so the country has learned to survive a disaster with minimal losses. Almost every building in Japan is equipped with dampers, which are devices that suppress any vibrations and make houses more resistant to shaking. In addition, on the shores of Japan, residents have built long and high shields that don't allow powerful waves to break through to land. Japan also has an advanced earthquake warning system. It's impossible to predict powerful seismic activity in a few days or weeks, but it's possible to detect small tremors that may portend an impending earthquake. Special devices monitor seismic signals and transmit the data to certain programs. Then, they evaluate the magnitude and intensity of the tremors and send warnings to people's phones. This can save seconds and even minutes for locals to reach the nearest shelter in time. These systems are also used to slow down the speed of trains, to stop work at factories, hospitals, and office buildings. It's much safer for a train driver to slow down during an earthquake than to rush forward at full speed. But what if you're on the street and you can't hear your phone messages? How to act in case of disaster? This applies not only to Japan, but also to any place where a tsunami or earthquake may occur. To survive a tsunami, you need to prepare for it long before a big wave hits. It's very important to have good relations with neighbors, be friendly with them, help them, and treat them well. In times of trouble or disaster, it's great to have people with whom you have a good relationship. They can help you get out of a difficult situation, and you can also help them. Be kind and compassionate to people. This way, it's much easier to survive any disaster. Prepare a backpack with necessities in advance. These are a first aid kit, canned food, flashlights, a battery-powered radio, and bottled water. All this will not only save your life, but will also help other people in trouble. So if you feel an earthquake start, immediately run for cover. If you're at home, try to stand against a wall closest to the center of the building, or crawl under heavy furniture that stands firmly on the floor, such as a desk or a regular table. Stay away from windows and front doors, and never use an elevator. If you're on the street, don't come close to power lines and any objects that may fall. During a tsunami, you may need to get as high as possible to avoid getting swallowed by water. Stay as far away from the shore as you can, and don't go down until you're sure it's safe. But how can you find out about an approaching wave if you haven't received the warning? When a tsunami approaches the shore, you will hear a roar similar to the rumble of a passing train or plane. If there's no elevation nearby, then try to get to the upper floors. It must be at least the third floor, but it has to be a building that can resist a tsunami, such as a massive house made of concrete. If there are no such high buildings nearby, try to climb a massive tree. When the disaster is over, look around and find those you can help. Listen to messages from rescuers via radio or TV. If all is well, then you can deal with the consequences. Yes, there's a lot of work ahead, but you've survived and helped others survive. And that's the most important thing. For 70,000 years, Taftan volcanoes successfully convinced everyone it was extinct. But new satellite images show that its summit is rising, like something inside is stretching it, rolling it over, and cracking its neck after the world's longest nap. Scientists aren't too happy about it, so let's see if you have a reason to be worried too. Volcanoes can wake up when earthquakes shake them awake or storms mess with underground water. But scientists checked. There weren't any big earthquakes or heavy rains in southeastern Iran, where it sits. So it must be gas or magma pressure that's moving Taftan. It's like a sealed soda can heating up from the inside. Before you even hear a hiss, the pressure is building silently, waiting for a weakness. That's why Taftan's movement is such a big red flag. Pressure changes mean new internal activity. Plus, the source of pressure below its surface is at just around 1,600 to 2,070 feet deep. And that's not a lot for a volcano. When the source of pressure sits that close to daylight, it can set off small explosions from steam or gas, even if no lava ever touches the surface. This type of explosion, called phreatic, happens when water underground gets so hot so fast that it blows up like a giant pressure cooker. In Hollywood movies, volcanic eruptions always look like rivers of lava chasing people down the street. But steam-driven explosions are different, sneaky, and unpredictable. One minute everything looks calm, and the next minute rocks and superheated steam blast into the air like Earth sneezed with the power of a jet engine. For Taftan, this is exactly the scenario scientists are afraid of. You don't need flowing lava to cause destruction. A steam-driven explosion can launch boulders the size of cars and shoot ash clouds thousands of feet up. Even if you don't live anywhere near Iran, Taftan isn't just a local issue. Volcanoes breathe out gases that travel with the wind, and Taftan produces sulfur-heavy emissions when it's active. Sulfur dioxide doesn't just smell bad, but messes with air quality, irritates lungs, and reacts in the atmosphere to form particles that can dim sunlight and cool temperatures. That means neighboring countries might feel the effects even if they never see the volcano. And if a phreatic explosion blasts ash high enough, it could drift into international flight paths like volcanic confetti nobody asked for. Even smaller eruptions can have ripple effects. Remember that time a volcano in Iceland with a name I won't ever pronounce correctly blew up in 2010? It disrupted all the air travel across the Atlantic, and in our case, a modest ash plume drifting into major air corridors could ground flights across the Middle East, South Asia, and beyond. You know, gas emissions don't respect borders. They drift, mix, and settle wherever the wind decides to drop them. Alright, all this sounds pretty creepy, but with all the modern sensors, scientists should find out about an eruption in advance, right? Not really. As Taftan sits in a really remote region, setting up monitoring stations there is tricky, expensive, and frankly, was never a priority because everyone assumed the volcano was done for. So right now, satellites, not ground instruments, are doing most of the work. Satellites see the big picture, but instruments on the mountain add detail. And that's why it was so important for Taftan to be reclassified from extinct to dormant. Because dormant volcanoes need eyes on them 24/7. When a volcano is labeled extinct, countries don't invest in evacuation plans, hazard maps, or monitoring equipment. Changing Taftan's status forced everyone, from local officials to global scientists, to admit it can cause trouble. And that means preparing for ashfall, gas emissions, sudden eruptions, and the long-term questions. Questions like, what if this awakening isn't temporary? What if this is the beginning of a whole new activity cycle? Long-term, Taftan might settle down again, or it might be entering a period of renewed activity. Volcanoes don't run on human timelines. A short-term phase for a volcano could be days or years, and the uplifting summit might mean there's deeper magma movement, not just a surface burp. It has gone up by about 3.5 inches over 10 months between July 2023 and May 2024. And a mountain rising is like Earth inhaling. And if Earth inhales too deeply, it eventually exhales. And in volcanic terms, that exhale is nothing good. Right now, Taftan is breathing in, and nobody knows when it plans to breathe out. This already sounds like too much drama, but there's more where it came from. Some of the biggest, angriest supervolcanoes on Earth are starting to wake up. When one of these monsters erupts, the whole planet feels it, even people living thousands of miles away. Scientists worry because a super eruption could move faster than our ability to prepare food, evacuate cities, or deal with the chaos afterward. That's what makes supervolcanoes so scary. Not just the explosion, but how little time we might have to react. If you live near Naples, you already know at least one supervolcano and how it acts. Streets crack, steam leaks from the earth, the harbor fills with sediment, and swarms of small earthquakes rattle windows like underground thunder. All of that comes from Campi Flegrei, a massive supervolcano caldera that last erupted in 1538. For years, scientists read these signals as classic warnings of magma rising. But two recent studies, one in 2023 and another in 2025, completely changed how we understand what's really going on. And surprisingly, they brought a bit of hope with the danger. In 2023, studies zoomed in on carbon dioxide, a gas volcanoes pump out when magma starts acting up. At Campi Flegrei, CO2 levels jumped after 2005 to about 4,000 to 5,000 tons a day, which sounds like magma rising fast. But when scientists checked other gases like nitrogen and helium, the chemistry didn't fit that idea at all. It turned out that the extra CO2 came not from rising magma, but from super hot fluids underground, cooking the surrounding rocks and releasing gas on their own. In the 2025 study, lab experiments showed that the shaking comes mainly from a sealed underground water and steam reservoir. When that natural lid traps pressure, it eventually cracks and releases steam and sets off sudden quakes that people feel at the surface. That idea also explains something that always confused scientists. The earthquakes usually start close to the surface and then move deeper, which is the opposite of what rising magma would do. After the strongest shaking, the ground often sinks a little, like a balloon slowly deflating after you let some air out. None of this means Campi Flegrei is suddenly safe though. Magma still sits deep underground, and steam-driven explosions can still blast out rocks, ash, and scorching gas without any lava warning you first. What's really changed is how scientists think about the danger. Just watching and waiting isn't enough anymore. If humanity only had 12 months of warning before a supervolcano eruption, we'd struggle badly. Stockpiling food, relocating people, keeping supply chains alive. It would all feel almost impossible. But don't freak out yet, because supervolcano eruptions are extremely rare. The last one happened about 26,500 years ago in New Zealand. On average, scientists think a super eruption happens roughly once every 100,000 years, but Earth doesn't follow neat schedules like a calendar. Sometimes these eruptions cluster closer together, and then the planet stays quiet for a long time. Two massive super eruptions shook the planet within the last 100,000 years. About 74,000 years ago, Indonesia's Toba volcano blew up with such force that it blasted ash across Asia, lowered the temperatures around the world, and may have pushed early humans to the brink of extinction. Then, around 26,500 years ago, New Zealand's Taupo volcano unleashed an eruption, covering huge areas in ash and reshaping the landscape we see today. There's always a chance another super eruption could arrive earlier than we expect. That uncertainty is what keeps scientists awake at night. Scientists are warning the next mega earthquake could strike off the coast of Japan at any time. And if we don't listen to them, this could be the most catastrophic one of all time. But the shaking won't be the biggest problem. The real threat will come a few hours later, and might even affect countries as far as the US. Seismic data shows a dangerous buildup of energy beneath the ocean floor east of Hokkaido. Basically, the Earth's crust is storing more and more energy, and it keeps increasing every year. The pressure is now so high, it could trigger a magnitude 9 earthquake. This is the most powerful and dangerous kind. It can destroy infrastructure, wipe out entire cities in seconds, and take thousands of lives. But the earthquake itself isn't even the worst part. The problem is that they often generate tsunamis just moments later, and they're even more destructive than the earthquakes themselves. These waves can cross the Pacific, reaching countries thousands of miles away with almost no loss of energy. The last time a megathrust earthquake hit Japan, back in 2011, the effects caused damage as far away as Crescent City, California. So not even people on the other side of the world would be safe when it strikes. And this time, there are far more at stake. What makes all this more concerning is that we don't know exactly when it will happen. Researchers in Japan say mega earthquakes strike the Hokkaido coast approximately every 340 to 380 years. The last such event occurred in the 17th century, roughly 400 years ago. So basically, the region is overdue, and based on past patterns, it should have happened already. The possibility of this disaster happening within the next 30 years has recently risen to around 90%, and this probably only continues to rise. That's why some people believe it could happen anytime soon. Japanese authorities know this isn't a question of if, but when. So they've built an entire system around that reality. They have one of the most sophisticated earthquake warning networks in the world. It's designed to detect the first seismic signals and send alerts in seconds, before the strongest shaking even begins. And when the network senses the first earthquake signals, it triggers an immediate chain reaction across the country. First, people will receive immediate warning alarms on TVs, radios, and smartphones. Then trains will stop, factories will shut down. Those signals can even turn off computers and stop elevators at the nearest floor. All of that happens automatically. They also mapped out evacuation routes in advance with clearly marked paths leading to higher ground. Even though the Japan Meteorological Agency is taking every precaution, they also advise, if you're planning to visit the country, pay attention to the news about seismic activity before you hop on a plane, because a disaster might happen anytime soon. At first, researchers thought their cameras were glitching. It was the only possible thing that could explain the weird view in front of them. Scalding water was blasting upward while cool methane was fizzing out right beside it. Such a combo wasn't supposed to even exist, but it did. Scientists were exploring the ocean floor near Papua New Guinea when they stumbled across a weird deep-sea hotspot. It wasn't like any other hotspot. There, super hot and cool methane-packed gas were bubbling out almost side by side. This almost never happens in nature, so the researchers were pretty shocked. They were cruising around with a deep-diving robot, the Rove Keel 6000, poking around underwater volcanoes in a remote island chain. These volcanoes hide all sorts of strange features, but nobody expected to find a full-on hydrothermal vent just tucked down there. Plus, other research trips had passed through the area before and missed it completely. This time, the robot's cameras lit up the seafloor and revealed a bizarre view: boiling vents and cold gas seeping out of the seabed. They were practically touching each other. As you understand, normally these two things show up in totally different places. Hot hydrothermal vents form when underground water gets cooked by magma and shoots upward, carrying minerals with it. Methane seeps, on the other hand, come from cold, mushy layers of sediment packed with old organic matter. This stuff slowly breaks down and leaks out as gas. But at this spot, the geology created a perfect mashup. Under the volcano sits a thick layer of organic-rich sediment. Magma creeping up from below heats these sediments, but at the same time, it also heats mineral-rich water deeper down. So you get two very different fluids, blazing hot vent water and cooler methane gas. Still, both are traveling upward through the same cracks in the seafloor. When they reach the surface, they escape just inches apart. So you end up with this bizarre little neighborhood where boiling mineral water and chilly methane bubbles are hanging out like best buddies. To ocean scientists, this is like discovering a unicorn that can also fly. It's weird, rare, and super exciting. An even more exciting thing is that right next to those weird hot and cold vents, an entire mini-world of creatures has taken over the rocks. The place is packed with huge clusters of deep-sea mussels, long tube worms, little shrimp, and amphipods crawling everywhere, and even bright purple sea cucumbers sitting out in the open. The animals are so crowded together that it's hard to even see the rock underneath. Scientists are pretty sure some of these creatures are totally new to science, but they need a special trip just to identify everything living there. The strange mix of hot fluids and methane-heavy gas also changes the rocks themselves. The methane down there is super concentrated, while hot water coming from deeper inside the volcano brings chemicals with it. Together, they create unusual reactions underground. Because of this, metals like gold and silver have built up in the rocks, along with elements like arsenic, antimony, and mercury. It's like a chemical time capsule. The rocks show signs of an older, super hot phase when precious metals were forming. Today, the vents are cooler, but still active. Now, even though this deep sea area is rare and full of life, it isn't safe. Mining already happens nearby, and waste from the huge gold mine on Lahir gets dumped into the ocean. On top of that, companies have licenses to explore the seafloor for minerals and gas. All of this puts the fragile vent community in danger because many of the animals here can only survive in these exact conditions. So scientists are urging for more research and strong protection plans before this one-of-a-kind ecosystem is damaged beyond repair. This underwater treasure needs to be saved before industry wipes it out. This discovery, though, isn't the only unique ecosystem we've ever found. In January 2025, a gigantic iceberg named A84, roughly the size of Chicago, cracked off Antarctica's George VI ice shelf. This ice shelf is enormous on its own, stretching about 280 miles from end to end and about 820 feet thick. During the Antarctic summer, which is November through late February, the top of the ice shelf melts and forms long, skinny pools called ribbon lakes. They got that name because they really do look like giant icy ribbons stretched across the surface. Once A84 broke free and drifted off, it exposed part of the seafloor that had been sealed away under the ice for who knows how long. It was a place absolutely nobody had seen before. A research team aboard the ship Falkor 2 happened to be in the Bellingshausen Sea at the time. As soon as they got word about the iceberg breaking loose, they ditched their original plan. This was basically the deep-sea version of flipping over a huge rock in the woods just to see what's living underneath it. For 8 days, the scientists sent down their underwater robot, Sebastian, and explored depths of more than 4,200 feet. Down in that freezing darkness, they discovered a hidden ecosystem packed with life. Huge corals and sponges formed underwater neighborhoods that were absolutely crawling with creatures. They were not just barely alive, they were thriving. So yeah, the scientists expected to find something down there, but they definitely didn't hope to spot a full-on underwater city of ancient life. There were sea anemones that looked like tiny fluffy trees, sea spiders marching around like creatures from other planets, ice fish, octopuses, and a whole mix of other animals. The entire expedition was live-streamed to researchers around the world. By the way, the recordings are still publicly available if you're interested. Even cooler, the researchers think some of the creatures they saw might actually be brand new species. That's right, genuinely new species in Antarctica in 2025. A few might live only in this one area, and that makes sense because Antarctica is basically its own isolated planet. It's surrounded by the Antarctic Circumpolar Current, which acts like a giant watery moat that has kept the continent cut off from the rest of the world for millions of years. But even if the new species ended up being known ones, the scientists still found some extremely rare animals, like tiny snails, bristly worms, aka polychaetes, little crustaceans, and even the mysterious phantom jellyfish, which already looks like something from outer space. The scientific name for the phantom jelly is Stygiomedusa gigantea, but no one really needs that mouthful, so giant phantom jelly is fine. This thing is massive. Its bell, the umbrella-shaped top, can be more than 3 feet wide. It also has 4 long ribbon-like arms that can stretch up to 33 feet. That's the length of a school bus. Actually, the first one was collected in 1899, but scientists didn't even realize it was a completely new kind of jellyfish until 60 years later. Its body is mostly see-through with a ghostly purple tint, and instead of normal tentacles, it uses those big flowing arms to grab prey and feed itself. Even though jellyfish don't have brains, the way this giant phantom jelly moved caught scientists off guard. It seemed to steer its long arms with surprising control, especially when it drifted through tight spaces near the seafloor. It looked cautious and almost intentional, which is kinda unsettling. Another maybe kinda sorta smart creature lurking in the dark ocean? Great. The researchers also found bristleworms. Officially, they're called polychaetes, but bristleworms sounds way more fun. These worms are common in cold, deep oceans and come in tons of shapes and sizes. Their bodies are made of segments lined with tiny bristles that help them crawl, sense the environment, and defend themselves. One standout is the Antarctic scale worm, which has shiny golden bristles that make it look surprisingly fancy for a creature living in freezing darkness. So, as you see, there are still tons of places and things on Earth that don't seem real or aren't even supposed to exist. And even with our level of technology, we're unlikely to figure out all the wonders the world has to offer in the near future.
Hey, can you lift a truck with your hands? No? Shocker. But let me introduce you to nature's original strongman, the ocean, which casually tossed 700-ton boulders around like they were pebbles during a mega tsunami that hit Africa thousands of years ago. This wasn't just a bad day at the beach. This mega tsunami was so powerful, it made the 2004 Indonesian and 2011 Japanese tsunamis look like kiddie pool splashes. Now, to give you an idea of how terrifying regular tsunamis already are, the Japan tsunami produced waves 133 feet tall. The Indian Ocean tsunami was slightly smaller, but it took over 200,000 lives across many countries. Now imagine something way worse. You see, for a long time, scientists thought waves that big were just science fiction. But then they found these enormous boulders, massive chunks of rock, flung far inland, and did the math. It turns out only waves around 800 feet tall could have pulled off that kind of rocky vandalism. And the culprit? A volcano that literally fell apart into the ocean and triggered one of the most powerful tsunamis Earth has ever seen. Usually, tsunamis are blamed on underwater earthquakes, tectonic plates getting into slap fights. But volcanoes? Oh, they've got tsunami potential too. In 1883, for example, a volcano in Indonesia named Krakatoa erupted for 6 months non-stop until it exploded, and the explosion was heard all the way in Australia. This triggered many tsunamis, some almost 100 feet tall. Still, that was more like a toe dip compared to the full cannonball from the mega tsunami. Back in ancient times, the volcano that crumbled during the mega tsunami was huge, and it didn't just fall apart. It lost a chunk that was 10 times the size of Mount Everest. 10 Mount Everests. It was like the Earth wanted to see what would happen if we threw a mountain into the ocean just for fun. It was so massive that when the entire side of the volcano belly flopped into the Atlantic, it created waves that could cover the Statue of Liberty 3 times. It also destroyed an island more than 30 miles away. The volcano behind this real-life Michael Bay scene was called Fogo, located on, you guessed it, Fogo Island. This island is basically just a whole single volcano that rose from the sea thanks to a magma hotspot, a place in the ocean where a lot of magma escapes and erupts like an underwater volcano. Over time, this magma cooled and stacked up like pancakes until, voila, after 7 major eruptions, the island popped out of the ocean like it was playing peekaboo. Surprise, it's a volcano. But Fogo's dramatic entrance was also a ticking time bomb. You see, the more a volcano grows, the heavier it gets, and if there's not enough magma inside it to support it, the whole thing can just collapse. Sometimes it doesn't take much. A minor earthquake, some erosion, or just a poor foundation made of soft sediment can trigger a collapse. It's like a really tall guy trying to balance over a bunch of marbles. Fogo had all the bad luck ingredients: too tall, too heavy, and built on squishy ground. And it gets worse. As the volcano grows heavier, it starts squishing the magma underneath. That lava can't rise, so it just simmers down there, slowly thickening like soup left on a burner for too long. Gases build up, pressure increases, and eventually, kaboom! It's the volcanic version of eating too many burritos and then trying to hold in a sneeze. This massive pressure and imbalance can trigger what's called a flank collapse, which is science speak for oops, half the volcano just fell into the ocean. That's what happened with Fogo. Most of the volcanic islands that form this way are long gone, but Fogo is still very much alive and kicking. In fact, it last erupted in 2014, and considering that it goes off every 20 years, maybe don't travel to Fogo Island in around 2034. For the longest time, scientists believe only big, bulky volcanic islands could collapse like this. But new research says that even smaller, skinnier guys, like the Danny DeVitos of the island world, aren't safe either. The thing is that small volcanic islands only seem stable because of their small mass. It's like Danny DeVito and Arnold Schwarzenegger both slipping on the ice. Arnie's fall might cause more chaos, but Danny can still go flying. And those little collapses? Yes, they matter. Take Santa Maria, a tiny island that's about 170 times smaller than Hawaii. It has collapsed multiple times, not because it wanted to, but because it's basically standing on soggy breadcrumbs. Its foundation is loose marine sediment, and to make things worse, it's sitting right next to the East Azores Fault, where 3 tectonic plates meet up for daily slap fights. This fault is responsible for many earthquakes and even some tsunamis that happened in Lisbon in the past, so you can imagine what it's like living right above it. Every time the volcano in Santa Maria erupts and grows, it also sinks. But when a chunk collapses, it bounces back up like a buoy. This seamount to island again roller coaster means that Santa Maria has popped in and out of the ocean like a submarine playing peekaboo. And with every peak comes a potential tsunami. Another volcano with similar trust issues is Pacaya, located in Guatemala. Between 2011 and 2013, scientists spotted strange movements in the soil, tiny shifts that suggested something underneath was getting restless. Sure enough, in 2014, Pacaya erupted. Luckily, it didn't collapse, but that risk still looms, especially if magma gets trapped in it like it did with Fogo. The consequences could be explosive, literally. In fact, about 1,000 years ago, Pacaya experienced a collapse that sent debris avalanches more than 15 miles away. Since then, it's rebuilt itself like a fiery phoenix, but it could still crumble again. That's why volcanologists obsess over the tiniest wobbles. It's not paranoia if the mountain really might fall. Now you might be thinking here, okay, but that was the past. Surely that kind of ridiculous mega tsunami collapse can't happen again, right? Well, welcome to the 21st century. Islands like Hawaii, La Palma in Spain, and various parts of the Caribbean are sitting on the same kind of geological whoopee cushions. All it takes is the right combo: loose foundation, steep slopes, maybe some trapped magma, and boom, flank collapse. In fact, it's already happened recently. In 2018, Anak Krakatau, the volcanic baby of the infamous Krakatoa, lost a big chunk of itself during an eruption. It caused a tsunami, but it was more awkward than devastating, like a volcano losing its pants on stage. Embarrassing, but survivable. But that's just amateur hour compared to history's real showstoppers. Ritter Island's 1888 collapse was so intense that the island literally got shorter. It went from being more than 2,000 feet tall to a mere 460 feet. But the record holder is the legendary Latua Bay megasplash from 1958, where a 7.8 magnitude earthquake triggered a massive landslide that sent a wave taller than the Empire State Building roaring through Alaska at highway speeds. Strangely enough, only 5 people lost their lives here, but on the other hand, the destruction path it left behind can still be seen today, all the way from space. Melting glaciers and ice caps can make volcanoes collapse too. When they melt, there's a sudden decrease in pressure on Earth's crust that can destabilize entire volcanoes. It's called isostatic rebound. It's like suddenly yanking a chair out from under someone who's been sitting still for centuries. Whoops. Also, here's something you probably never thought you'd worry about on your island getaway. Some volcanic islands grow outward as lava pours into the sea, creating unstable platforms known as lava deltas. These deltas can collapse without warning, taking newly formed land, and sometimes tourists too, right back into the ocean. No pressure though, just thought, maybe you want to stay off steaming new land. So yeah, next time you're lounging on a beachy volcanic island thinking, wow, this place is paradise. Just remember, it might also be a ticking geological time bomb with a flair for the dramatic. From ancient mountain-sized cannonballs to surprise lava deltas, volcanoes have a history of keeping things spicy. Our planet's biggest and meanest supervolcanoes are waking up. When they erupt, You'll surely notice it, even if you live thousands of miles away from the epicenter. Scientists are worried we might not have enough time to prepare and deal with the consequences of a super-eruption. There's some volcanic activity close to the Italian city of Naples. And no, it has nothing to do with the famous Mount Vesuvius, but with another volcano. This one is harder to see as it doesn't have a tall peak like Vesuvius. But don't let this bad guy trick you. It could be way more dangerous than its giant neighbor. It does have a huge crater that's about 8 miles wide. This volcano is called Campi Flegrei, and it's actually one of the largest volcanoes in Europe, sitting under the town of Pasquale. So, Campi Flegrei erupted 39,000 years ago with a bang so massive it spread ash across the whole Mediterranean region. It also caused the temperature to drop by over 16 degrees Fahrenheit across Eastern Europe. It was the biggest volcanic eruption in Europe in 200,000 years. Since then, Campi Flegrei has had smaller eruptions, and the last one happened in 1538. Now the area is full of small craters, hot springs, and bubbling pools, and they're all proof that this volcano is still very much alive and brewing something. Since the early 2000s, the ground in the giant crater and the town nearby have been slowly rising by about 1 to 1.5 inches every year. There were at least 150 earthquakes that shook this supervolcano lately. In May 2024, there was a 4.4 magnitude in the area, the biggest in the last 40 years. Residents had to leave their homes and camp outside, fearing there would be more earthquakes. No one knows how Campi Flegrei is going to behave in the following months or years, but the authorities are organizing evacuation exercises to prepare the population just in case. The Italian volcano looks like an innocent kitten compared to the real giants like Yellowstone. For a volcano to deserve the title of a super one, it must be able to produce catastrophic-scale eruptions and eject huge amounts of magma, ash, and volcanic gases. The Yellowstone giant meets these criteria. Even though it moves from time to time, the Yellowstone supervolcano hasn't erupted for 640,000 years. But when it does wake up, it might erupt with incredible power, about the same amount as 10 huge nuclear power stations can produce. Under the ground, beneath Yellowstone, there's a super-hot area full of molten rock called magma. As more magma moves into a big space called a magma chamber, the ground above starts to swell or rise. When the magma cools down, the ground falls. Between 2004 and 2009, the ground at Yellowstone rose by almost 10 inches, but then it started to slowly go back down in 2010. Scientists aren't sure if it's going to erupt anytime soon. There's also another big volcano called Long Valley in California that has been active since 1980, and it can be a really big threat. Scientists studying this supervolcano found out that before its biggest eruption, 760,000 years ago, the buildup may have taken less than a year. Now, that's bad news, because a supervolcano eruption can have a huge effect on the world, like the eruption of the Toba volcano in Sumatra around 74,000 years ago. It became the biggest volcanic eruption the Earth had seen in 28 million years. It covered parts of Indonesia, India, and the Indian Ocean with a thick layer of volcanic debris, almost like a 6-inch blanket. The amount of rock it spewed out was like stacking nearly 3 million Empire State Buildings. The giant crater it left behind can still be seen from space. All the ash and gases shot up into the air and blocked some of the sunlight. It caused a volcanic winter that lasted about 6 to 10 years. Some scientists think this eruption might have even affected early humans. Around the time Toba erupted, the human population took a sharp dip, and there were far fewer people. Some say this is why all modern humans come from a small group of survivors. According to the Toba catastrophe theory, most early humans in Europe and Asia didn't survive the cold and harsh climate after the eruption, but a lucky group lived through all that in Africa. Not all scientists agree with this idea, and some archaeological and climate records show a different story. Another volcano that changed the world in a big way was Mount Tambora in 1815. The next year went down in history as the year without a summer. It was cold and rainy, and there was snow and frost even in the middle of summer, especially in Europe and North America. This happened because the volcano sent out a lot of sulfur dioxide into the sky, which spread all over the world and made the planet colder. When Tambora erupted, it caused huge tsunamis that smashed homes and took the lives of around 10,000 people. Afterward, about 80,000 more people passed away because of the consequences the eruption had caused in the world. The cold weather ruined crops, so food became really expensive. And because horses were the main way people traveled, the cost of oats that they ate went way up too. Some people even think this led to the invention of the bicycle in 1817 as a new way to get around. The eruption made the Earth colder for about 3 years. Now, even though the Tambora eruption was so powerful, Krakatoa, another volcano in Indonesia, stole the show when it erupted in 1883. It was just easier to spread information about it through telegrams and photos. Its final blast was the loudest recorded sound in history, and people could hear it on 10% of the entire Earth's surface. The eruption started a tsunami, with waves about half as tall as the Statue of Liberty. Now, if we only had 12 months to prepare for a supervolcano eruption, it would be really hard to store enough food and get ready. But don't panic just yet. Supervolcano eruptions are very rare, and the last one happened 26,500 years ago in New Zealand. Scientists think that a super eruption happens once every 100,000 years on average. But the sad part here is that the Earth doesn't follow a perfect timeline. There could be clusters of super eruptions with shorter gaps between them and then longer quiet periods. Since there have already been 2 super eruptions in the last 100,000 years, there's always a chance one could happen again sooner than we expect. Plus, although there are places like Yellowstone and Long Valley where we expect volcanoes to erupt, there are less obvious possible hotspots. In Chile, there's a volcano called Laguna del Maule that has erupted in the past and left behind a huge crater. Over the last 20 years, the ground there has been swelling really fast, rising up to almost 1 foot a year. Some people are worried that this could be a sign of a big eruption coming. But scientists say there's not enough magma yet to cause a super eruption. In Bolivia, the Juturancu volcano is also acting up. It's part of a group of volcanoes that have caused super eruptions in the past. Since the 1960s, the ground around Juturancu has been lifting, but the last eruption was 250,000 years ago. Even though the magma might be rising, it's not enough to worry about just yet. The chances of a super eruption happening during our lifetime are 1 in 1,400, which is pretty low, so you don't need to worry too much. But just like someone wins the lottery every week with very small chances, a super eruption could happen sometime in the future, and when it does, we'll need to be prepared.
Scientists just found out that the Earth's crust beneath the Marmara Sea is sending seismic signals that look exactly like the kind that show up before a major earthquake. An earthquake that can shake entire coastlines and send waves racing toward crowded cities. For years, scientists focused on visible ruptures on land because they could measure and map them easily. But now, they made a detailed map of a huge fault system under the seafloor. The Mediterranean already sits at a dangerous crossroads where massive tectonic plates meet. Those plates push, scrape, and stretch against each other, and that constant motion creates massive stress. The crust there grows thinner over time, and thinner crust means it can't absorb stress easily. Stress builds, pressure mounts, and the signals coming from below show that parts of this fault system have started to move in unusual ways. The new map shows that future large earthquakes may begin at the boundaries where weaker and stronger sections of the crust meet, or along edges of highly resistive zones. They even pinpointed one of the most likely locations, beneath the Marmara Sea. What makes this discovery so intense is the scale. The faults in the seabed form long corridors where energy can accumulate for decades or centuries. Scientists warn that this setup is the kind that can produce a super earthquake, a massive seismic event capable of shaking large coastal cities and possibly generating tsunamis. A tsunami forms when the seafloor shifts vertically and displaces huge amounts of water, so it looks really plausible in this setting. The water it sets free radiates outward in powerful waves that can cross entire seas. The Mediterranean holds dozens of densely populated shorelines, so it could affect millions of lives. Speaking of that, let's zoom in on Istanbul, Turkey's largest and most populous city. The massive fault line sitting right under it doesn't act the way scientists thought it did. For years, experts looked at the main Marmara Fault, a branch of the North Anatolian Fault running beneath the Sea of Marmara, and worried it might rip in one single monstrous rupture. That kind of break could unleash a megaquake in the high 7s or beyond. But when scientists ran detailed computer simulations covering more than 10,000 years of earthquake cycles, they saw something different. The fault doesn't behave like one giant zipper waiting to unzip all at once. It behaves more like a row of connected tiles that break in sections. And the reason comes down to what's happening miles below the seafloor. It's called rheology. Simply put, how materials deform under stress, how rocks bend, stretch, or snap when you squeeze them hard enough. Under the central Sea of Marmara, giant piles of compacted mud, sand, and debris sit on top of warmer crust. In those upper layers, the sediment usually deforms slowly and steadily, especially at shallow depths where pressure and heat interact in specific ways. Deeper down, higher temperatures weaken the rocks. Warm rock flows more easily than cold rock. That heat acts like a built-in brake system that limits how far a rupture can tear through the crust. When researchers built a 3D earthquake cycle model, they fed in real heat flow measurements, rock friction data, and structural details, and replayed thousands of years of seismic activity. When they included both sediment thickness and temperature differences, the model finally matched history, including the powerful quakes of 1766 and 1912. And none of the simulated events exceeded magnitude 7.3. That level of shaking can collapse buildings, fracture infrastructure, and cause landslides. But it differs from the nightmare scenario of one continuous coast-to-coast rupture. Instead, different sections behave in different ways. The western segments produce more regular earthquakes, including magnitude 7.2 events roughly every 150 years. The eastern sections generate smaller double quakes, back-to-back events between magnitude 6.2 and 6.8 about every century, and a magnitude 7.0 roughly every 500 years. Parts of the fault don't snap at all, but creep. Scientists call it shallow creep, which just means the fault slowly slides without producing a major quake. It releases tension quietly, like letting air out of a balloon instead of popping it. GPS measurements and clusters of repeating small quakes over the past 20 years confirm that slow slip near the central basin. So what does this mean for Istanbul, a city of over 15 million people sitting practically on top of this system? A magnitude 7 or 7.3 quake close to the city could still rock neighborhoods, especially if two strong events strike in quick succession. Infrastructure, older buildings, and densely packed districts are at the highest risk. The fault hasn't produced a major rupture in this section since 1894, which means there's more than 130 years of accumulated strain. The simulations show major events could strike in the coming decades. Then there's Santorini, where more than 28,000 earthquakes happened in just a few months in early 2025. Most of the quakes stayed small, but some reached magnitude 5, strong enough to fracture walls, rattle nerves, and push authorities to close schools and evacuate parts of the island. And this wasn't just tectonic plates grinding like they usually do. This swarm moved. The epicenters shifted gradually northeast toward the Colombo submarine volcano about 5 miles offshore. That migration told scientists magma was on the move. Researchers calculated that roughly 80 billion gallons of it, enough to fill about 120,000 Olympic swimming pools, surged upward from depths around 11 miles beneath the surface. It climbed fast, then stalled about 2 to 2.5 miles below the seafloor. And all this was going on along the Hellenic Arc, one of Europe's most active subduction zones, where the African plate dives beneath the Eurasian region. Earthquakes often migrate across that span toward nearby islands. History backs that up. The 1956 Amorgos earthquakes unleashed massive shaking and a tsunami across the region. So, when 28,000 tremors light up the seismic network, you pay attention. This episode changed how scientists understand volcanic swarms. Now they know magma can intrude, fracture miles of crust, reshape underground reservoirs, and still never surface. It can load the system for the future without pulling the trigger today. And that matters because when magma moves like this, it changes stress fields underground and how future quakes might breed. The good news is that scientists now have really cool monitoring tools that feed real-time seismic feeds, underwater pressure sensors, and repeated gas measurements near volcanic vents into integrated hazard models. If magma starts accelerating upward again, researchers will see it and will take action. And there's another bold new idea in earthquake and tsunami warning: using undersea internet cables for this purpose. Nearly 1 million miles of those fiber optic lines on the seabed were designed to carry data, but scientists discovered that they can also detect tiny changes in light signals caused by seismic vibrations. In simple terms, when the ground shakes, the cable feels it. And this could be incredibly useful because forecasting earthquakes, even on land, is tricky. In the ocean, it has felt almost impossible as you can't scatter thousands of sensors across the seafloor easily. But those cables already sit there, stretching across deep trenches and continental shelves. If researchers use them as sensors, they can monitor tectonic movement in real time across huge areas. For a region like the Mediterranean, with hidden faults, active volcanoes, and crowded coasts, that system could offer precious seconds or minutes of warning. Seconds sound small, but early alerts let trains stop, gas lines shut down, and people move away from immediate danger. The fiber optic cable used for Seafloor Project, or FOCUS in the short version, didn't warn anyone about real disasters yet, but it had 2 false alarms. It reacted to a submarine landslide and weight bags that pushed the cables down. It proves the system works and could be life-saving in case of real danger, especially in vulnerable regions such as the Mediterranean. It shaped civilizations for thousands of years, and now science reveals it still shapes itself. They can't stop tectonic plates or cool magma chambers, but they can understand patterns, reduce vulnerability, and design cities smarter. The Panama Canal is beginning to collapse. This is one of the most important shortcuts in the world, and nearly 6% of everything shipped by sea goes through it. But when water levels dropped, fewer ships were able to get through and companies had to look for other ways to move goods. Now, a new billion-dollar rail corridor is taking shape in Mexico, and it could change the future of shipping forever. We'll get into that bold project in a moment, but first, we need to understand why the Panama Canal matters so much and why we need other options fast. So, the Panama Canal is basically a 51-mile man-made passage between the Atlantic and the Pacific. It was constructed back in 1914, and today it's considered one of the 2 most strategic waterways in the world. The other one is on that level in the Suez Canal. To see why it matters so much, let's look at a map. If a ship sails from the east coast to the west coast of the United States, it would normally have to go all the way down to Cape Horn at the southern tip of South America. But with the Panama Canal, that trip is about 8,000 nautical miles shorter. So yeah, it's a huge difference. It's not just the US that benefits from it. The Panama Canal also saves a lot of time for ships traveling between Europe and East Asia or between Europe and Australia. It also helps ships move more quickly between ports from one side of North America to the other side of South America. The Panama Canal is like the perfect solution. It gave the world a faster and easier way to move goods between countries. Around 14,000 ships go through it every year. Those ships carry more than 500 million tons of food, minerals, and manufactured products. That's about $270 billion worth of cargo. This passage was built and controlled by the US at first, but since 1979, PANA has been in charge. Keeping this canal running has become a huge challenge recently. The country has been hit by severe drought over the last 3 years, and when it doesn't rain enough, water levels in the canal drop, so ships get stuck. A big part of the problem was caused by the well-known El Niño. This natural phenomenon makes ocean waters in the central and eastern Pacific warmer, and that completely changes weather patterns in many parts of the world. In the US, for example, that often means warmer weather in the north and wetter conditions in the south. In Panama, it usually means drought and less rain. Thanks to it, the region got about 40% less rain than usual from late 2022 to 2024. That is a huge problem for trade, because the Panama Canal relies completely on rainwater to operate. Lake Gatun, one of the canal's main water sources, started drying up too. The lake normally sits around 87 feet, but it fell to just 81.8 feet. As the water level dropped, they had to cut the number of ships allowed through the Panama Canal. Normally, about 34 ships cross it every day, but at one point, that number fell to just 18. The result was a traffic jam, with some ships stuck waiting for about 3 weeks to get across. That quickly turned into a much bigger problem for global trade. The traffic slowed down the flow of key products around the world. We're talking about things like oil, grain, canned food, iron, steel, and a lot more. And when ships started piling up like that, prices usually started climbing too. So companies had to find other ways to move their products. That's far from ideal, because the other routes are much longer, slower, and more expensive. Let's say a product is coming from China to the US East Coast. Instead of going through the Panama Canal, the ships might have to go through the Suez Canal, adding about 7 days to the trip. And if it is headed to the US Gulf Coast, it may have to go all the way around the Cape of Good Hope, which can add at least 10 more days. All that extra time means extra costs, and the rates on major trade routes went up by 20 to 30%. A lot of e-commerce shipments got caught up in this too. Deliveries started slowing down, especially in Latin America. Some companies then started shipping their products by plane, and that's a lot more expensive. That extra cost usually gets passed on somehow, either through higher shipping fees or higher prices. When that happens, some people may just stop buying from certain online stores. That's bad for everyone. Things are a little better now though. The region was recently affected by La Niña, which is the opposite of El Niño. This brought heavy rain back to the area and Gatun Lake filled up again. It actually came close to its maximum level in early 2026. That was a huge turnaround after the extremely low levels of the past few years. Okay, traffic on the canal is still lower than it was before the drought, but at least things are moving again. Getting the water levels back up was a huge relief, but it may not last. Specialists now believe El Niño could return later in 2026. In fact, they're even talking about a possible super El Niño, the kind that can push global temperatures to record highs. If that happens, the region could be hit by another round of severe drought, and it could be even worse this time. So if things slow down in the Panama Canal again, what's the other option? Well, Mexico may have an answer. For years, they've been working on a rail route in the south of the country to connect the Pacific Ocean to the Caribbean Sea. It's called the Tehuantepec Interoceanic Corridor, or CIIT for short. The idea is not new at all. It goes all the way back to 1907, but only now is it finally starting to become real. This massive infrastructure project was approved in 2019, and since then, it has received around $4 billion in investment. Its main goal is to compete with the Panama Canal, but it's also meant to do much more than that. They want it to bring new industry into the towns and cities along the route and help turn southern Mexico into a major center for logistics and manufacturing. The plan is built around 3 new rail lines, but that's only part of it. They will also upgrade 2 major ports along with new industrial projects, gas pipelines, and highways. And to attract private companies, Mexico is also offering major incentives across 4 states: Veracruz, Oaxaca, Chiapas, and Tabasco. Basically, the idea is to move some shipments across Mexico by train, instead of sending them through the Panama Canal. That could ease some of the pressure and give companies another way to move their goods when problems start piling up. The project is expected to be fully completed by June 2026, but it's already up and running. Not long ago, Hyundai tested the route by moving 900 vehicles on the CIIT rail line. Before, a shipment like this would take about 6 days to cross Mexico. But with this new rail system, it took just 9 hours. That's why authorities say the CIIT could become a key route for moving goods from the Pacific to the Atlantic, and vice versa. That is where things stand today. The Panama Canal is still a key route for global trade, but it's under more pressure than ever. At the same time, Mexico is building a bold new alternative that could open a different path between two oceans. It's still too early to say how far this project will go, but one thing is certain. When one of the world's most important trade routes begins to slow down, everyone starts searching for what comes next.
Something enormous is hiding right below Hawaii, deeper than any drill could ever reach. This strange underground bubble, almost 1,800 miles down, tells us impressive new details about the formation of the islands and could cause an eruption that will affect thousands of lives. Scientists call strange formations like this blob ultra-low velocity zones. When earthquakes happen, they send vibrations through the planet, and they move fast through most rocks, but they slow way down when they pass through certain deep layers. That slowdown tells geologists something unusual sits there. The giant blob beneath Hawaii belongs to the biggest category of these structures, a mega ultra-low velocity zone, a massive chunk of material sitting right on the border between Earth's mantle and its core. To find out what this monster actually looks like, scientists track two different types of earthquake waves. The first type, pressure waves, compresses rock like squeezing a spring. Another type, shear waves, moves rock up and down like shaking a rope. When they combined both signals, researchers built a much clearer picture of what lies deep below Hawaii. Scientists used to think that this blob was soft and partially melted, like thick lava slowly rising toward the surface. But this new seismic data showed that the blob isn't gooey at all. It's mostly solid rock, dense, heavy, and packed with iron. This discovery helps explain a real mystery that puzzled scientists for decades. Most volcanoes form along the edges of tectonic plates, but Hawaii doesn't sit anywhere near one of those boundaries. It floats right in the middle of the Pacific plate. Yet the islands somehow form from some of the most active volcanoes on the planet. They used to explain this with a hot spot, a column of heat rising from deep inside the Earth like a blowtorch slowly melting its way upward. But now, it turns out that the giant iron-rich blob anchors that heat plume in place, like the base of a lava lamp that keeps the flow steady for millions of years. The material the structure is made of could even be leftovers from a basal magma ocean, a gigantic layer of molten rock that may have existed deep inside Earth when the planet first formed. When that ancient ocean cooled and crystallized, heavy elements like iron sank downward and created dense pockets, and the blob under Hawaii might be one of those survivors. Now, structures like this don't just sit quietly forever. Heat constantly flows through Earth's mantle, and when those flows shift, they can tug on deep structures, redirect heat, and sometimes destabilize them. If the system beneath Hawaii ever changes in a major way, it could intensify the volcanic activity above. We already see hints of that restless energy. Hawaii has thousands of earthquakes every year. Most of them are tiny, so small that only sensitive instruments detect them. On average, Hawaii has about 100 magnitude 3 earthquakes per year. Those are strong enough for people to feel. Roughly 10 quakes reach magnitude 4 annually, and about 1 magnitude 5 quake shakes the islands every year. Bigger events happen less often, but they still happen. Most of this activity is going on around the Big Island, which has several volcanoes. In early March 2026, Kilauea launched fountains of lava nearly 1,300 feet into the air. Bright red streams of molten rock blasted upward, and ash and volcanic fragments rained down across nearby areas. Authorities temporarily closed parts of Hawaii Volcanoes National Park and sections of Highway 11 because falling debris created dangerous conditions. The eruption didn't threaten homes directly, but it still caused real problems. Ash drifted across nearby communities, and tiny rock fragments coated roads and rooftops. All that activity connects to the same deep engine, the hotspot anchored by that enormous iron-rich blob nearly 1,800 miles beneath the islands. Now, let's travel north, where something pretty scary lurks beneath the western edge of North America. Something capable of reshaping the entire coastline. Scientists think that two giant earthquake faults, the Cascadia subduction zone and the San Andreas fault, don't just exist side by side, but may actually affect each other and act like giant dominoes. Cascadia stretches along the Pacific Northwest, and the San Andreas cuts through California. Scientists found evidence for this possible impact on the ocean floor. They pulled long cylinders of mud and sediment, and these cores are like geological history books that preserve layers of debris from ancient earthquakes. Inside those layers, researchers saw that pairs of earthquake deposits sit almost on top of each other. Geologists call them doublets. Two massive quakes struck so close together in time that the ocean barely had time to settle between them. And that discovery points straight to one of the most chaotic tectonic zones on the planet, the Mendocino Triple Junction. This is where three tectonic plates collide and grind together, like crooked gears inside a machine. It's also the exact place where the San Andreas Fault meets the Cascadia subduction zone. Now, when one fault ruptures, it sends shock waves of stress through the crust. That stress can destabilize the neighboring fault and push it toward breaking too. A Cascadia Megaquake alone could reach magnitude 9 or higher. That kind of earthquake could tear open 600 to 700 miles of seafloor and send a massive tsunami racing toward the Pacific coast. And if Cascadia ruptures first, the shifting stress might trigger the San Andreas shortly afterward. In the worst-case scenario, people in California could feel one enormous quake, watch buildings sway and highways break apart, and then see a second disaster just minutes later. And the opposite sequence could happen too. The San Andreas could snap first, redistribute pressure through the crust, and nudge Cascadia to failure. In this case, people living in the affected area might survive the first quake and then see the ocean suddenly pull away from the shoreline. And that's the chilling signal that a tsunami could arrive in about 20 minutes. Scientists know from analyzing the sediment that this sequence has happened before. There were at least 10 paired earthquakes over the past 3,100 years. The scariest part is that a new massive earthquake isn't about if, it's strictly about when. Now let's jump across the Atlantic to southern Italy. Just west of Naples, there's a massive volcanic system called the Campi Flegrei caldera. It means something like burning fields, and it earned that title honestly. About 109,000 years ago, a huge eruption blasted ash and rock across the region. It removed more than 36 cubic miles of magma from beneath the surface. It's a volume close to the massive eruption that formed the Campi Flegrei caldera around 40,000 years ago. That earlier eruption carved a crater about 9 miles wide and spread volcanic ash across huge parts of Europe. Today, more than 400,000 people live directly inside that ancient crater. The soil there feels incredibly fertile because crops have grown on broken-down volcanic ash for centuries. But the same geology that makes the land productive also hides enormous energy underground. Researchers recently studied ancient rock layers preserved in mountains and deep boreholes around the region. That's how they found out that Campi Flegrei may produce giant eruptions more often than scientists previously believed. That doesn't mean a catastrophic eruption will happen anytime soon, but it does change how researchers see the long-term danger. When these eruptions occur, They don't behave as ordinary lava flows. They generate pyroclastic flows, and those are fast-moving avalanches of hot gas, ash, and rock that race across the ground at highway speeds. Some ancient deposits from that eruption, more than 100,000 years ago, reach more than 6 feet thick in certain places, which proves just how violent the bang was. When you connect all these discoveries together, you once again see that our planet doesn't just sit quietly beneath our feet. It moves, breathes, and occasionally reminds us who really runs the place. And most of the time, the biggest forces shaping our world hide thousands of miles below where we stand.
There is a huge monster machine hiding under Tokyo that can swallow rivers. Engineers built it to protect one of the biggest cities on Earth from typhoons that can flood entire districts in hours. They placed the world's largest flood control system about 164 feet underground, where it waits like a silent shield against storms. When extreme rain hits, this system grabs water from multiple rivers and takes it away from streets, homes, and subways before damage begins. One powerful typhoon could drown Tokyo, but this underground water deity makes the flood simply disappear. Most people in the city never see it, even though a concrete giant has already saved their neighborhoods more than 100 times. It's really needed here as Japan sits in one of the most dangerous weather neighborhoods on the planet. Warm ocean currents smash into cold air, and that clash breeds typhoons. Add mountains that squeeze clouds like wet sponges, and rivers swell fast. Tokyo doesn't sprawl on flat desert, it spreads across lowlands where water naturally wants to collect. When rain falls too hard, it rushes downhill like a crowd leaving a stadium. Before protection systems existed, floods chewed through neighborhoods, destroyed infrastructure, and forced families onto rooftops. That's why Tokyo authorities had to come up with a solution. Let me introduce you to this big boy, the GCANS project, officially called the Metropolitan Area Outer Underground Discharge Channel. Engineers carved it beneath normal suburbs, not downtown skyscrapers, because that's where rivers sneak in first. The system drops as deep as a 50-story building turned sideways into the ground, and it feels like walking inside a forgotten sci-fi temple. Its heart is a hall almost 580 feet long, supported by 59 concrete pillars, each roughly the height of a 7-story building, and weighing about 500 tons, the same as a fully loaded Boeing 747. During typhoons, the city literally dumps rivers into the earth. Multiple waterways across the Tokyo region connect to this system like veins leading to a mechanical heart. Gravity pulls water through more than 3.7 miles of tunnels, sloping at precise angles so nothing stalls, nothing backs up, and nothing panics. Engineers calculated every inch like surgeons planning an operation. If they mess up, water will flood the neighborhoods. The tunnels act like underground highways, moving floods away from homes and straight into the belly of the system. Then come the pumps, absolute beasts. Each one stands about the size of a small house and roars to life when water climbs too high. Together, they can move about 7,000 cubic feet of water per second. That means an Olympic swimming pool drains in about 12 seconds. The pumps don't fight nature, but redirect it. Since the system went live, operators have activated it more than 100 times. Each activation means a disaster that didn't happen. In 2008 alone, GCANS absorbed more than 413 million cubic feet of water, enough to cover entire districts. The project took almost 14 years to finish and cost around $2 billion. Engineers treated every bolt like a life decision because mistakes underground don't break equipment. They break cities and lives. On calm days, the halls feel abandoned and eerie. On storm days, they become Tokyo's invisible superhero. Dozens of operators work in real time, watching river levels, rainfall maps, and flow speeds like air traffic controllers for water. They talk constantly, adjusting gates, valves, and pump speeds. The crazy part is that most residents never visit the structure that guards them. Tourists walk the streets, ride trains, take selfies, and have no clue that beneath their sneakers, rivers stand in line waiting to get eaten by concrete. GCANS doesn't stop typhoons, as nothing can do it, but it buys time, space, and safety. It's like installing airbags into the Earth itself. Floods aren't Japan's only nightmare. The islands sit on the edge of 4 tectonic plates. When they grind, they release energy as earthquakes. About 1,500 earthquakes every year. Most of them feel tiny, but some shake cities like soda cans. Before modern engineering, quakes flattened wooden houses, snapped bridges, and turned streets into puzzle pieces. So Japan rewrote the rules of architecture. Instead of building stiff towers that snap like dry branches, engineers designed buildings that move. They use shock absorbers, sliding foundations, and flexible joints. When the ground shifts, buildings sway instead of breaking. Today, about 87% of new buildings in Japan can survive major quakes, and many older ones get upgraded with modern tech. Some towers even use massive pendulums inside that swing opposite to the quake, canceling motion like noise-canceling headphones for buildings. Others sit on rubber pads and steel rollers, so the entire structure slides instead of shattering. Homes, schools, offices, quake resistance lives in Japan's architectural DNA.
Is het geleden dat de stormramp over het zuidwesten van ons land kwam. In deze dagen zullen er velen zijn.
Japan isn't the only country taming the elements. There's an incredible mega project in the Netherlands, the Delta Works. The Dutch face a more constant threat, the North Sea itself, pushing relentlessly against the land. They've had to deal with the water for so long that nearly a third of their country sits below sea level, and millions of people live where the sea would happily pour in if nature got an opening. In 1953, a massive North Sea storm surge drowned nearly 1,836 people and took huge tracts of farmland and towns, and that gave birth to the Delta Works, a chain of gigantic dams, storm surge barriers, locks, and dikes. It took more than 40 years to finish. Engineers built a defensive web in the southwestern Netherlands to shorten vulnerable stretches of coastline by hundreds of miles and reduce the land exposed to storm surges. The heart of the mega project is a 6-mile-long structure made of towering concrete piers and massive floodgates that can close when rough seas threaten. Most of the time, those gates stay open, letting tides flow and keeping local marine environment healthy. But when a huge storm is coming, operators activate the system, and the gates rise up like a steel fortress across the sea. The Delta Works dams and dikes turned tidal estuaries into calmer freshwater lakes and opened new possibilities for agriculture, travel, and nature reserves. Roads and bridges now cross waters that used to separate islands from the mainland. Even though much of the system was finished decades ago, modern conditions keep nudging engineers to think about the future. Rising seas and bigger storms mean the Dutch have to keep upgrading their barriers and reinforcements. Now, let's move to Venice, Italy. It literally floats on a lagoon, with canals weaving between ancient buildings and piazzas barely higher than sea level. That beauty comes with a serious problem. When the Adriatic Sea pushes in with unusually high tides, called acqua alta, historic streets, churches, and landmarks can vanish under feet of water. After a brutal flood in 1966, Italy decided something had to change, and they built MOS, or Experimental Electromechanical Module. It's not one wall or one dam, but a series of 78 massive steel gates hidden on the seabed at the 3 openings that connect the Venetian lagoon to the Adriatic Sea. Under normal conditions, these barriers lie completely flat under the water, invisible to boats and tourists. But when forecasts predict dangerous high water, operators pump compressed air into the hollow barriers so they expel water, float up in under 30 minutes, and create a temporary wall between the sea and lagoon. This wall can hold back tides up to about 9.8 feet above normal sea level. That's powerful enough to protect the city from most historic flood events. When the danger passes, water refills the barriers and they sink back down. Engineers designed MOs so that the gates can operate independently or in groups, which means extra flexibility depending on how the water behaves. That precision matters because the lagoon isn't just water, but a fragile ecosystem that needs tidal flow to stay healthy. MOs has taken decades to build, seen cost balloons and delays, and sparked debate over whether it's enough for rising sea levels. But when the gates rise and keep Venice dry during high tides, people get a glimpse of what modern engineering looks like when it battles both history and the sea.
Now, you'd think a fire would go out when temperatures drop to 32 degrees Fahrenheit. But not in the Arctic. Over there, summer fires can survive all winter, hidden deep underground. But these flames eventually come up again and become a problem for all of us. They release more carbon into the air, bringing hotter days and more fires and floods. So the real threat is not visible. It's only waiting, lurking underground. These zombie fires are becoming more frequent in the Arctic. Now I know we usually link the region with glaciers and snow, but it can also catch fire. The Arctic has boreal forests with trees like spruce, fir, and pine. These trees get buried deep in snow during winter, but when spring comes, the ground is exposed and the plants dry out. So if lightning strikes the region, for example, it can easily start a fire. When temperatures drop again, the fire seems to go out, but it only looks that way. In reality, it becomes what scientists call a holdover fire. It can survive freezing winter for months under layers of dirt and snow. And it manages to do that because of peat. No, not this peat. This peat. Peat is a layer of soil made of plant material that has been decomposing for tens to thousands of years. With enough oxygen, fires can burn slowly and spread underground by feeding on peat. And you won't see a single flame above the ground. Then, when spring arrives and the snow melts, the fire can come back up. Sometimes it reignites in the exact same spot where it burned the year before. That's when the real problem begins. Boreal forests store a huge amount of carbon. When they burn, the carbon in the trees and peat is released into the air and cannot return to the soil for hundreds of years. That makes the planet warmer. It's a dangerous cycle. Warmer conditions can lead to more severe fire seasons and more zombie fires. Those fires release even more harmful emissions into the air, which makes things even warmer. This also makes fire seasons much harder to predict. In Canada, for example, authorities say spring is getting warmer and drier and the snow is melting earlier. That means the risk can start growing before the usual fire season even begins. So what happens in the Arctic will affect the rest of the world. That's why scientists are developing new tools to better understand this event. New satellites and artificial intelligence are helping them track what starts these fires, how much fuel is on the ground, and how easily it can burn. The more they learn, the better we can prepare for the next threat underground.
Although it looks perfectly doable, there's still no bridge connecting Great Britain and Ireland. There are a whole bunch of reasons that prevent engineers from starting the construction. One of them is way darker than budgets or bad weather. It's a reason most people never even hear about, and we'll get to it in a moment. So, the first reason why there's still no bridge in one of the most logical positions is geography. The most direct route would run from Scotland to Northern Ireland across the North Channel, the narrowest stretch between the islands. On a flat map, it looks manageable. In reality, that channel behaves like a pressure valve between the Atlantic Ocean and the Irish Sea. Storm systems sweep in straight from the Atlantic with almost nothing to slow them down. In winter, winds roar across the water at speeds strong enough to shut down major bridges. Engineers can't plan around calm days and light breezes. They have to prepare for the worst storm that might hit once in a century. And in this stretch of water, that worst-case scenario looks brutal. Towering waves, violent gusts, and conditions that test even the toughest marine structures. Another problem is that parts of the North Channel drop hundreds of feet, and the seabed has no smooth, level surface ready for construction. It falls away into jagged rock, sharp ridges, and deep trenches. A long span bridge needs solid foundations. Crews would have to drill and anchor enormous pylons into hard rock beneath rough, moving water and juggle strong currents and short weather windows at the same time. Offshore oil platforms survive harsh seas, but they stay fixed in one place and don't have traffic constantly moving on them. A 20-mile bridge moving cars and trains every minute would have to look like a chain of massive offshore towers linked together across one of Europe's most unpredictable marine corridors. Then comes Beaufort's Dike, the most sinister reason that pushes the idea from extremely difficult to almost reckless. This deep underwater trench lies between Scotland and Northern Ireland. After the dramatic events of the 20th century, UK authorities dumped enormous amounts of surplus munitions there, possibly more than 1 million tons. Any construction team would first need to survey the entire area, map every hazard, and decide whether to remove or avoid them. One mistake could damage the environment or trigger a detonation. Before workers could place a single pier in the water, they would have to arrange a cleanup operation so massive that it would be one of the largest hazardous waste projects ever. Now, add money to the equation. When the officials did some math, they figured out it would cost between $272 billion and $455 billion to build either a bridge or a tunnel here. For perspective, that rivals the GDP of some smaller countries. It could fund entire national rail overhauls, renewable energy transformations, or decades of healthcare investment. Countries don't spend that kind of money unless they know they'll get some economic return, and it doesn't look like traffic demand here will cover the expense. The volume of people and goods traveling between Scotland and Northern Ireland simply doesn't match crossings like the English Channel between Britain and France. Alright, fine, forget the bridge, but why not dig a tunnel? They don't depend on wind conditions, but not everything is so simple here either. An Irish Sea tunnel would cost almost $300 billion and take around 30 years to complete. It would be way longer and more complex than the Channel Tunnel, and become the longest undersea rail tunnel ever built. Crews would drill under deep water, through complex geology, and beneath a seabed contaminated with munitions. Engineers would also have to face a technical problem with rail gauge. Great Britain uses the standard gauge of 4 feet 8.5 inches, and Ireland has a broader gauge of 5 feet 3 inches. That means trains from one network cannot simply roll onto the other. A fixed rail tunnel would need new infrastructure, dual gauge systems, or major upgrades across both islands. So the tunnel wouldn't just connect two coasts, it would mean massive rail reconstruction inland. Costs would balloon even further. The weather would keep causing trouble long after the final bolt went in. Powerful crosswinds would sweep across a high bridge and force traffic to stop without warning. Salt water would eat away at exposed steel every single day. Crews would have to face corrosion, replace parts, and secure loose elements while Atlantic storms pounded the structure year-round. This would never become a structure you build and forget. It would demand attention every week of its life. If you think, but the Channel Tunnel is managing somehow, remember, it runs beneath far calmer waters and avoids direct exposure to wind and waves. The North Channel gives no such protection. And at the same time, transport across the region already works well. Ferries cross the Irish Sea in a matter of hours. Airlines run frequent routes between Belfast, Dublin, Glasgow, and London. You can find affordable tickets and reach your destination quickly. The current network moves people and goods efficiently. This pattern repeats in other places as well. Let's move south toward the Strait of Gibraltar, where Europe almost touches Africa. At its narrowest, the strait is just about 9 miles across. And that sounds temptingly short, but the currents rip through that narrow gap between Spain and Morocco with some of the strongest forces you'll find anywhere on Earth. And as if that weren't enough, that stretch of water sits right on the seam where the African tectonic plate and the Eurasian tectonic plate press against each other. The African plate inches north every year, only a couple of inches annually, which sounds harmless unless you remember that continents weigh trillions of tons. When those plates grind, they stick, strain, and then snap. That snap sends out earthquakes, fractures the seabed, and shifts the ocean floor without warning. Even if engineers somehow anchored a bridge across it, the currents would hammer the structure day and night, shaking bolts loose and stressing every joint unless designers overbuilt it to an extreme degree. When you look at the depth, the challenge drops, literally, to another level. Parts of the strait plunge close to 3,000 feet, taller than many skyscrapers. Any support columns, known as piles, would need to stretch almost half a mile downward, drilled and secured into unstable seabed rock. Engineers would probably have to assemble them in enormous reinforced sections and bolt them together like pieces of a steel spine. And after installation, the structure would still face earthquakes capable of snapping rigid supports like dry twigs. Plus, the strait functions like a giant breathing valve between the Atlantic Ocean and the Mediterranean Sea. The water entering the Atlantic carries lower salinity, and the Mediterranean water contains more salt, and therefore weighs more. Two-layer exchange creates powerful vertical mixing, swirling eddies, and turbulence zones that look almost like underwater storms. All that turbulence lifts nutrients from the deep and feeds phytoplankton. Blasting, drilling, or dumping construction materials into that environment would hurt phytoplankton and the entire sea food chain. Because of all of that, a tunnel here sounds like a smarter alternative. It took engineers roughly 2 decades of research and planning, and now, construction is supposed to start here around 2030, with about 10 years of work before trains could realistically run beneath the strait. Even then, builders will fight pressure, heat, rock density, and the constant reality that 2 continents continue nudging toward each other inch by inch beneath their feet. The tunnel is supposed to plunge down to more than 1,000 feet below sea level at its deepest point. It would stretch close to 25 miles, with roughly 17 miles running directly beneath the seabed. If it does work out, high-speed trains could carry passengers and freight from Spain to Morocco in about 30 minutes. And that's not just convenience. That's a rewiring of trade routes, labor movement, and tourism, and economic gravity between continents. More than 12 million people could travel on that route every year, so the tunnel will really be life-changing. Take a look at Australia from space. Nothing unusual, right? But now, focus on the northern territory of the continent. If we imagine it through magnetic sensors, we notice, whoa, see that? An unknown strange thing that mirrors the outline of Australia itself. It looks almost the same, but smaller. It's like a twin of the continent hidden deep within it. But what is it? Volcanic lakes? Gold deposits? No, it's something far stranger. This is a magnetic anomaly. Yeah, you're probably confused, but let's find out what's going on with Australia. So, there are devices called magnetometers. They measure magnetic fields, and geologists use them for many things, including exploring the interior of our planet. The magnetic field comes from various metals and minerals buried deep underground. It travels upwards, and scientists' sensors detect it. One day, they equipped aircraft with these magnetometers and flew over the northern part of Australia. When they processed the data and identified a magnetic anomaly with clear geological boundaries, whatever lay in Australia's interior was emitting magnetic signals and followed the outline of the entire continent. And because these signals come from deep rocks, scientists think that valuable resources, including minerals and metals, might be hidden there. But beyond potential resources, what else does this tell us? Inside these rocks, there could be volcanic materials formed over 1.5 billion years ago, minerals that formed long before the dinosaurs appeared. This entire mass of material could tell scientists about our planet's history and how the Australian continent was formed. Okay, that sounds cool, but why are those changes in the magnetic field they detected called an anomaly? Why is it magnetic in the first place? And how does this magnetism work? To understand, we first need to grasp what Earth's magnetic field is. And this is one of the most amazing and mysterious things in the world. The magnetic field is invisible, yet without it, we couldn't exist. So, in simple terms, Earth's magnetic field is our protective blanket, shielding us from cosmic radiation, charged solar particles, and the solar wind. Without the magnetic field, our Earth would be like Mars, a barren desert where life most likely couldn't have emerged. But where does it come from? The magnetic field is generated deep within our planet, where molten nickel and iron create electrical currents. Combined with our planet's rotation, these electrical flows generate the magnetic field that protects us. In addition, minerals and metals inside rocks can produce magnetic fields too. But what exactly is this force? Take two magnets from your fridge and try to push them together. Feel that resistance? That repulsion happens because their magnetic fields are interacting. In some places, this magnetic field can be weaker, and in others, stronger. This means that deep within the planet, in those locations, there are geological processes happening that change the stable behavior of the magnetic field. These places are what we call magnetic anomalies. One of them lies beneath the northern part of Australia. However, the magnetic field is more than just a blanket. Thanks to it, many awesome things happen. For example, a compass needle always points north because the Earth's south magnetic pole is located there, attracting the magnet. Don't confuse the geographic and magnetic poles. The geographic North Pole is in the north, near the magnetic South Pole. It's not just humans who use the magnetic field for navigation. Animals can do it too, without any instruments or technology. Some animals sense the magnetic field, and this superpower is called magnetoreception. This ability helps animals during migration. That is, they know where north and south are. So when it gets cold, they can fly to where it's warm. For some turtles, magnetoreception helps them remember the location of feeding areas. Pigeons have a unique perception of the magnetic field too. In simple words, the magnetic field is also a giant navigation system for many creatures on Earth. Few people know, but we actually have a second magnetic field. In 2018, scientists published research describing how ocean tides create another magnetic layer. But why hadn't we noticed it before? Our main magnetic field, generated by the planet's core, is very strong. Its radiation extends into space and is easy to detect. The magnetic field from tides is almost 20,000 times weaker. How does this field affect the main one? What are its properties? Scientists continue to study these questions. Also, the magnetic field can control the brain. In 2017, scientists used magnetic fields to remotely activate brain cells in mice. Magnetic forces were directed at the parts of the mouse brain responsible for body movement. In this way, the scientists could make the rodent run, freeze, and turn around. But don't think this was done just for fun. Experiments like this can be very helpful for humanity. If you can make a small animal move, imagine what other changes might be possible in the brain. Improving psychological state, for example. Potentially, you could instantly switch from a bad, depressive mood to a happy one. This technology could help treat many diseases related to the brain and nervous system. You might think that such a technology could control you, but don't worry. Magnetic fields pass through your tissues with almost no effect. But then, how did they manage to control those mice? Scientists simply implanted tiny magnetic particles into the animals' brains. Under the influence of a magnetic field, these particles heated up and triggered the activation of neurons. But the coolest thing happens when the magnetic field collides with the solar wind, generating electrical currents and magnetic forces. At the moment, a true cosmic storm happens in the sky, and we see it in the form of beautiful auroras. Such storms are not only beautiful, but also destructive, as they can disrupt the operation of satellites and electronic devices. Sometimes this can lead to minor glitches in your GPS or internet connection on your phone. But there have been cases where magnetic storms were so massive, they led to catastrophic consequences. One of them occurred in 1859 and is known as the Carrington event. On September 1, 1859, an amateur skywatcher, Richard Carrington, noticed a sudden bright white flash on the sun. It turned out this flash was a massive ejection of plasma from the sun's upper atmosphere. About 17 hours later, part of this energy reached our planet and struck as a powerful storm. All telegraph systems at the time went down. The northern lights were visible not only to residents of northern regions, but also in the tropics. For many people who had never heard of or seen the northern lights, this was a real surprise. What must they have thought? The end of the world? Unknown forces from space? Many were undoubtedly shocked by the spectacle, but the real shock was inside major cities. Communication between telegraph systems was stopped. The world was plunged into an eerie silence. Sparks flew from telegraph machines, causing fires in some places. People couldn't send or receive important information. Fortunately, the consequences weren't too catastrophic. Communication technologies were just beginning to develop at that time. But what would happen if such an event occurred today? Many experts have estimated that the damage from a similar storm in the United States could reach up to $2.6 trillion. The entire internet would shut down. For a while, we would lose access to our messaging apps, our banks, our navigation systems. Contactless payments, airports, train stations, and much more would stop working. We would be cut off not only from the internet but also from electricity for a long time. The entire planet would be plunged into darkness and silence. A global economic and humanitarian crisis would begin. It's hard to imagine the damage that AI would suffer. But don't worry, the good news is that storms like this happen roughly once every 500 years, and smaller ones about every 50 years. But these aren't precise forecasts, since it's quite difficult for scientists to predict the sun's behavior. Besides, we wouldn't just sit in shock after such an event, we would immediately begin dealing with the consequences. The impact on modern civilization from such a storm would be significant, but we would surely recover quickly. 7,500 years ago, the Pacific floor collapsed. Massive landslides buried the seabed in seconds. Fast forward to today, robot subs have examined the place. Scans have revealed proof of at least 10 distinct cyclical megaquakes. Now, researchers warn, the plates are still locked and building pressure, even today. If they start moving, that could trigger new red alert earthquakes and send disastrous tsunamis toward the coast. Let's look at the map. The fault here is like a giant zipper. It's over 600 miles, stretching from northern California to Canada. It's called the Cascadia Subduction Zone, and it's a part of the Ring of Fire. You know, the famous giant horseshoe around the Pacific that can serve as your where-to-go reminder if you're into volcanic and earthquake tourism. One of Cascadia's biggest events happened around the year 1700. There are no local written records of it, but there is a story. A well-known indigenous legend tells of an epic battle between a thunderbird and a whale. In the story, the thunderbird's wing beats make the ground shake. The whale's thrashing sends seawater flooding inland. The thunderbird wins by finally grabbing the whale and slamming it back down, shaking the land itself. Many researchers believe that this legend originated from the real earthquake of 1700. But we don't just have cool myths to give us the full picture. In the early 1700s, samurai officials recorded waves flooding villages and rice fields. But nobody felt the earthquake that must come first. That's why they nicknamed this event the Orphan Tsunami. But it did have a parent, and it took scientists 300 years to finally connect it back to Cascadia. To see Cascadia's past, researchers sent robot subs to scan the bottom in crazy detail. They expected to see a simple crack, but what they found looked more like giant underwater steps. Some of those steps are about 33 feet tall, like a 3-story building. That only happens when a big piece of the seafloor snaps off, breaks loose and slides all at once, not slowly. When that happens, it kicks up a mud avalanche. Picture a jar of dirt and water. Shake it hard, and a fresh layer settles at the bottom. Each layer is basically a timestamp from a huge quake. When scientists counted and dated them, they found 10 separate megaquakes that hit one after the other over thousands of years. That means that Cascadia doesn't let pressure out little by little. It stays stuck for a long time, then suddenly breaks out violently. That pattern is why the Cascadia subduction zone is considered one of the scariest fault systems in North America today. So what's actually happening down there? The plates aren't sliding smoothly, they're stuck. And while they're stuck, the coastline is getting quietly bent out of shape like a ruler you're flexing in your hands. It doesn't look dramatic day to day, but it's been loading up for centuries. When that tension finally snaps, the coast will instantly drop. Geologists call this co-seismic subsidence. We're talking about the ground plunging 6 to 8 feet vertically in a matter of minutes. Imagine standing on a beach. The shaking stops, and you realize the ocean is rushing in. Not just because of a wave, but because the land you're standing on has physically sunk below sea level. That one move is enough to shove the seafloor out of position and force the ocean above it to react. Cascadia can produce a magnitude 9.0. That's top tier, categorized as the most destructive natural event that can happen. It can shake the ground for minutes, pushing and pulling everything back and forth until buildings and bridges start falling down. A 9.0 class quake also means the seafloor is vibrating and shifting, lifting in some spots, dropping in others, all in one sudden motion. A tsunami starts when the seafloor moves and pushes a huge amount of water out of the way. If the bottom suddenly lifts or drops, the water above it gets displaced instantly. That water has to go somewhere, so it races outward in every direction. Out in deep water, that wave is rarely tall. It spreads out across a long distance, so it can pass under ships without anyone noticing. The danger is speed. In the open ocean, tsunamis can travel around 500 to 600 miles per hour. That's like traveling from New York to Detroit in 60 minutes. Eventually, the ocean starts to pile up, getting taller by the second. Near shore, it can stack up to tens of feet, and in extreme cases, it can run up to 100 feet on land. It swallows the coast, then drags everything back to sea with a violent tug before the next hit arrives. But that's not all. When the fault snaps, it often triggers massive underwater landslides. When a huge chunk of seafloor collapses, it can shove water locally, like dropping a boulder into a tub. In the Cascadia subduction zone, you aren't just dealing with the earthquake's kick. You're getting a 1-2 punch from the shifting crust and the crumbling slopes combined. On parts of the Oregon coast, emergency experts say the shaking could last 5 to 7 minutes, long enough to realize what's happening and still won't be over. Then comes the scariest part. In some places, a tsunami can hit in 15 to 30 minutes. Remember, the earthquake is a warning. If you're on the coast and you feel strong, long shaking, you do not need to wait for a text alert or a siren, or someone on the news to yell tsunami. During the tremors, the basic recommendation is to literally drop to the ground, cover, and hold on, staying away from windows and chandeliers that can fall on you. As tempting as it is, we shouldn't stop to make a reel out of the situation. Before anything happens, make one decision while your brain is calm. Pick the closest high ground and go for it. Not somewhere uphill, an actual spot. If you ever needed a reason to learn your neighborhood, this is it. Your instinct might say, get into the car and drive. But don't. Roads are probably jammed and bridges could be damaged. People who live on the coast already know to keep it practical, with shoes on the bed and a go bag prepared just in case. The danger doesn't end with the first impact because the tsunami waves, well, they come in waves. The initial hit is rarely the largest, and the ocean can continue to pulse in and out for hours. This creates a violent tug-of-war. The receding water acts like a massive vacuum, dragging anything caught in the backwash out to sea. Japan's 2011 disaster is the most recent vivid example of what a magnitude 9.1 can do. The seafloor shifted in a single massive heave, and minutes later, the ocean literally rearranged the coast. A huge wall of water crashed inland, reaching over 100 feet high in some spots, and turning the coastline into a conveyor belt of debris. It was like water turned cars into giant bowling balls and shipping containers into massive metal bricks, smashing ports and drowning low-lying airports and electrical substations. Finally, what do officials say about the timeline for the possible next disaster hitting Cascadia? Well, they can't give us precise dates, but they did announce some odds. For the biggest, scariest earthquake possible, the United States Geological Survey says there is about a 10% to 15% chance it'll happen in the next 50 years. Chances for a quake that isn't the mega version are 1 in 3 in the next 5 decades. Those odds are actually pretty high. But here is why it isn't all that grim. Scientists know this isn't random. Cascadia has a pattern, and patterns are what preparation runs on. We already know how to build for big shaking, and we're getting better at spotting where stress is building. It doesn't mean we can stop the earthquake, but it means we're getting way better at knowing what to expect. In the meantime, just keep a go bag by the door and maybe take a walk around your neighborhood every once in a while.